Hi, it's Carly McAvoy. I want to do some binomial practice with you, solving probabilities using a binomial model. So an Olympic archer is able to hit the bullseye 80% of the time. Assume each shot is independent of the others. If he shoots 6 arrows, what's the probability of each of the following results? Remember, to be able to use this, we want to say these 3 things. Is the same probability every time, that remains constant. The previous trial doesn't affect the new trial, and there's only 2 outcomes. In this case, he either gets a bullseye or he doesn't. Okay, so what's the probability that his first bullseye comes on the 3rd arrow? Just looking at our notation here, our n is 6 because he's shooting 6 arrows. P, probability of success, is 80% or 0.8. And remember, P and Q have to add up. This is probability of success, this is probability of failure. So we have 0.2 and 0.8 because they add up to 1. You always just take 1 minus P to get Q. And then this notation is showing you that we're using our probability of success. Is defined by a binomial model where n is 6 and the probability is 0.8. So for the first one, though, he wants to have his bullseye come on the 3rd arrow. So what's happening is he misses, and then he hits that. So what's the probability of that happening? And that looks like QQP, a failure, and finally a success. Failure is 0.2, 0.2, and then success is 0.8. And if you multiply that, you get 0.32. Or if they asked you to put it in percentage form, that would be 3.2%. And the second one, it's saying he misses the bullseye at least once. So for this one, it's a little different because we're talking about missing. And so actually, we're going to use the Q as our success because we want to know how many times if he's missing. We're not asking that he gets the bullseye. So because we're saying we're missing it, we're going to actually use Q as our success here. So that's a little bit confusing. But the GeoGebra.org/classic gets me to this page, and sometimes if this wasn't showing, you could come up here and click and get the ... and get to probability calculator that way. So you can click on probability as soon as you get there, or if you don't see it, you can click on it up here. And then we don't want all this stuff over here. So if you click this, you'll get your 3 dots here. You can close that window, and you'll see these 3 dots, and close that window because that's all we really want. Now we are in a distribution, but right now we're in a normal distribution and we want binomial. So we're going to do the drop-down menu and go down to binomial. Once we get to that, we can see that they had n equals 20 and our n is actually 6. So we don't really want to have that. And then we also have our probability. In this particular question, we're talking about misses. So that probability is 0.2. And then we're being asked, he misses it at least once. If you're saying at least once, it's like saying you have to be at least 21 to get into a bar, right? You could be more than 21, but you can't be less than. So if we're talking about at least something, we're talking about greater than or equal to. That is, it could at least once, maybe twice, maybe 3, 4, 5, or 6 misses, right? So at least 1 miss. So we're going to come down here and replace that 8 with the 1, and that shows us it's 0.7379. And so that would be our probability. We don't have to do any calculations by hand or a calculator. Just use GeoGebra for that. And you can see this is kind of backwards, but you can see that arrow opens to the X, right? Just like ours does. We're talking about greater than when we talk about at least. Okay, here's one where he gets exactly 4 bullseyes. And these probabilities tell you the exacts. So exactly 4 is, we want to make sure we put in 0.8. Because now we're talking about getting the bullseye. That's different, right? But the other one was about missing. So we need to make sure that we put in that. And then we can come right up here to where it says 4. What is the probability that he gets exactly 4 bullseyes? It's right here, 0.2458. So that would be that. And again, if you were asked to give that as a percentage, it'd be 24.58. Just look to see what your directions say. What about he gets at least 4 bullseyes? We're going to use this because we're talking about getting a bullseye, not missing. And we want at least 4, just like we saw with at least 1. When we're talking about at least 4, we're talking about it could be 4, 5, or 6 in this case. So we want to do greater than 4. And that gives us 0.9011. It's basically adding these 3 numbers together. You could get 4, you could get 5, or you could get 6. at least 4 would be all those added up. And so that's going to give us that number, 90.11% or 0.9011. What about he gets at most 4? And most 4 would be he get 4, or he could get 3 or 2 or 1 or 0. The most you could have, right? Like you're talking about how many people fit in your car. The most you could have is 5, but you could have less, right? So when you're talking about at most, you're talking about less than or equal to, and we are talking about less than or equal to 4. So we're talking about all of these things, 4 or less. This is 4 bullseyes, 3, 2, and 1 bullseye. So that's 0.3446. And then looking at this one, it's a little different. It's asking, what is the probability that his first bullseye comes on the 4th or 5th arrow? Because of the word or in here between 4th and 5th, we're going to add the two probabilities together. And we're going to do it the way we did it up here, where we're looking at P, P, Q, whatever. That's going to be how we're doing it, rather than using the GeoGebra for this. So what we're talking about is if it happened on the 4th arrow, we would have miss, 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 success, right? We'd get a bullseye on the 4th time. Whoops, it looks like I'm missing something there. I want the P there. So this one we're having Q, 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 and then P. So that tells us that we finally did get a success on that last time, which was the 5th arrow. So what does that look like if you're calculating the probabilities? This looks like failure, 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 so 0.2 to the 3rd power times success, plus failure, 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 0.2 to the 4th power times 0.8, and that gives you 0.0077. Now, if it asks you how many bullseyes do you expect him to get, that would be the average or the expected value of that, and that's a very simple formula. It's just n times p. Our n was 6 and our p was 0.8, so we would expect to get 4.8. Look up here, that already is given, so you don't really have to do that calculation if you remember that it's right there on GeoGebra already. But if you didn't remember that, you could do that very simple formula to get it. Similarly, if we're asking for standard deviation, it's the square root of NPQ. That is 6 times 0.8 times 0.2. Square root of all that gives us 0.9798, which is what we get here. So that would be our standard deviation. So you can get that on GeoGebra, or you can do it using those simple formulas, whichever. All right, that's it for this. Have a fantastic day, and I'll see you next time.